Thanks very much, Lisa. Yeah, how amazing. Congratulations to all those teams, and well done, Ariane 5, for delivering this special payload into space. What an amazing moment. For those who've just joined us, I'm actually in Germany, where they actually fly these spacecraft and out to Jupiter. And I'm with Rosario, and we were just getting onto a Twitter question, which was, how is JUICE going to be able to explore the moons in depth when it's out once it's in orbit around Jupiter?
Yeah. A funny way to look at this is to imagine JUICE as a 6-ton beast, and the instruments as the senses of this beast, and the way it perceives the world, and in particular the Jovian moons. For example, the eyes of this beast will be the remote sensing instruments that will be watching at the surface and the atmospheres of the moons and see which is their composition and the processes that are going on there. Also, when we will be close to the moons, the probe will wear special goggles to see the surface in 3D, to see the geology of the surface, and also to penetrate a few kilometers and see how these first layers look like. Does it mean that we cannot go farther inside and see the structure inside the moon? For this, we have the in situ instruments that will be continuously smelling and tasting the environment, touching the plasma, the particles, and feeling the magnetic field and the radiation around the probe. So everything together, also together with the way the probe is feeling its weight with respect to the gravitational pull it receives from the moon. The moons, everything together will allow us to understand the internal structure of the moons, and among other things, to know why there are and why and how and where the oceans of liquid water are, and if they are habitable.
Yeah, I mean, it's when you described it as an orchestra and getting ready, it actually sounds more like that you have to be an orchestral musician and a ballet dancer at the same time.
Yeah.
It's amazing.
Yeah,
so you've got all these science objectives. So how do you as a scientist, do you deal with all the expectations, and how does the spacecraft itself deal with all those expectations and this huge orchestral complex piece that it has to play when it gets out there?
Yeah. Well, we think that the hardest part of this orchestra is to jungle between what we want and what we can. So on one side, we have our dream of unveiling some of the secrets of Jupiter, and all the instruments want to play together at the same time and as long as possible, because every single bit of data is important for the science return. But on the other hand, the spacecraft imposes us strong constraints, and this is because we have constraints on power and on data generation. Why is this? Because we are at Jupiter, and this means that we are very far away from the sun. And even if we have these huge solar panels that could power up several houses on Earth, they can only power up something similar to a microwave at Jupiter distances. So, sometimes we have to choose among the instruments that can be switched on at the same time. On the other hand, being at Jupiter means that we are very far away from the Earth also, and this means that the data transfer is very slow. For example, if we had a 2-hour film on board JUICE, it will take several days to be transferred to the Earth. So all in all, a lot of constraints that forces us to lighten the instrument operations and to choose to trade off and to make hard decisions, but always trying to preserve the scientific objectives.
Yeah, it's hugely complicated.
Yeah.
I mean, so that's why you need this 8 years. It's actually quite convenient that you've got all this planning time. Yeah.
It will be short
at
the end.
Yes, I know. It's like anything, isn't it? You think, 8 years, I've got ages pages.
No. It's right there.
So, yeah, what are the plans for, all this data coming back to Earth? Presumably people are going to be poring over this for years. What are the plans for the data when it gets back?
Yeah. Once the data are here, the instrument teams are the ones that know how to cook them to be usable for the scientists. So they will cook the data, they will be stored in an archive, and then they will be shared among the whole community to be exploited for the years to come, as you said, and who knows, to inspire new missions to revisit this incredible
mission
world.
Yeah. I mean, it's one thing that it really strikes me that these things take a long time to develop. We heard from Frederick, take a long time to develop, and then it takes a long time to get there, and then it takes a long time to actually process the data. This, for some scientists, this is a life's work, isn't it?
A lifetime work, yes.
So do you think there will be a juice moment? Do you think you'll have a moment where you go, oh, this is amazing?
Well, who knows? Yeah. We had, there was the Galileo moment when, as Anesina was saying, Galileo discovered Jupiter's moons. We can think about a second Galileo moment when the Galileo probe showed that these worlds are not as cold and as dead and as inhospitable as it was thought before. And this changed completely our understanding of the universe and the way we search for life beyond the Earth. And who knows if we will have a huge moment that will also change completely our understanding of the solar system. So let's hope for the best.
Yeah, absolutely. Thank you so much, Rosario, for giving us all that information about JUICE. It's what an incredible mission. For those who are just joining us, you can ask more questions of more of our guests, and we'll try and get them answered